Welcome to this explainer. Today, we are taking an absolutely epic, cinematic journey. We're going to track the massive macro forces that shape our entire planet and then funnel all of that raw power down into a micro case study of India's spectacular mountain peaks.
Here is our roadmap for today. We'll start with the forces beneath us, see how the Earth is sculpted by water and ice, explore our deserts, coasts, and plains, and finally zoom in on India's northern ranges and the peaks of the peninsular Deep South. Now, before we even talk about the solid ground we stand on, we kind of have to acknowledge the elephant in the room, or, well, the ocean. Our Earth is actually 71% water. When our planet formed over 4.5 billion years ago, it was just hot molten rock. That massive ocean formed from the continual degassing of the Earth's interior, releasing steam that cooled into literally millennia of rain. And it's exactly that water that serves as the fundamental sculptor for the 29% of land we actually live on.
All right, part one, the forces beneath us and exactly how mountains rise.
You know, towering giants like the Himalayas, they aren't just static rocks sitting there. They are the offspring of violent plate convergence. Picture this, gigantic continental plates colliding in a literal slow-motion car crash. The Earth's crust bends, breaks, crumbles, and is just forcefully pushed upwards. In fact, the collision that created the Himalayas began 50 million years ago. And get this, it is still happening beneath our feet right now. But wait, that brings us to a massive geographical paradox, doesn't it? If these mountain peaks are literally being pushed miles up, closer to the blazing radiation of the sun, why in the world are they capped with freezing ice and snow?
Well, the answer is all about altitude. See, as you climb, the air pressure just tanks. So when warm air rises from the base of the mountain, it expands in that thin atmosphere and instantly loses its heat. Plus, you're getting further and further away from the radiant heat of the Earth's core. And with cooler air, there's way less evaporation, which leaves behind incredibly dense moisture. At those freezing high altitudes, that moisture has nowhere to go but down, falling as snow, which gives us those iconic white peaks.
Moving right along to part two, sculpted by water and ice, the literal carving of the Earth.
Now, nature's erosive tools, they have totally different styles. Think of massive, slow-moving glaciers as giant sheets of sandpaper. They just relentlessly grind down the Earth over millennia, leaving behind these wide, sweeping, U-shaped valleys. On the flip side, rivers are more like a surgeon's scalpel. Their continuous, forceful downward flow rapidly slices these sharp, dramatic, V-shaped valleys straight into the bedrock. And when all that water finally hits the coastlines, it leaves some very distinct signatures. Let's look at the difference between a gulf and a bay. A gulf, take the Persian Gulf for example, is basically a super deep oceanic trench formed by intense tectonic activity like subduction or cracking. But a bay, that's more of a broad, semicircular curve into the landmass. It usually happens when the ocean simply overflows a drifting coastline, kind of like the massive Bay of Bengal. Heading further inland, we run into wetlands, and separating them comes down to one absolute golden rule, the vegetation. If you're standing in a wetland and all you see is grass and herbaceous plants, you're in a marsh, no trees in sight. But if you see woody trees and thick mangrove forests anchoring down the muddy soil, like in India's famous saltwater Sundarbans, you are definitely in a swamp.
Okay, let's zoom out a bit for part three, deserts, coasts, and plains. Earth's vast expanses.
When I say desert, you're probably picturing blistering hot, endless sandy dunes, right? Well, actually, there are 4 distinct types. We've got the classic hot and dry ones, sure, but there are also rain shadow deserts, literally trapped on the dry leeward side of mountain ranges. Then there are coastal deserts, smothered in heavy fog from cold ocean currents, but getting absolute zero rain. And get this, polar deserts, places like Ladakh or even Antarctica. The one unifying trait linking all of them together isn't the heat, it's a severe, hostile lack of humidity and moisture.
And right at the edges of these colossal expanses, we find the coast. Now, a coast is so much more than just a place to put your beach towel. It is a violently dynamic boundary. Every single day, thanks to the relentless energy of crashing waves, shifting tides, and massive sediment dumps from rivers, sandy coastlines are completely wiped clean and redrawn.
Which brings us to part 4. India's mighty northern ranges. Let's dive into our case study.
When we apply all these massive macro forces to India, the sheer variety of terrain is just mind-blowing. Up in the far north, the Karakoram Range is home to the legendary, towering K2 Peak. Just south of that, the Pir Panjal and Daladar ranges gorgeously enclose the Kulu and Manali valleys.
As we sweep east, the Dafla and Abor Hills offer the absolute perfect elevation for world-class tea production. And the Patkai Boom Mountains, they act as a massive natural fortress wall right on the border with Myanmar. Pushing deeper into the northeastern states, we hit this incredibly vital cluster of geographical formations. You've got the famous Garo, Khasi, and Jaintia hills, which are all crowned by the Nokrek Peak. Then, a bit further south, the Naga and Mizo hills proudly rise up, with the Mizo hills boasting the towering and honestly aptly named Blue Peak. Finally, let's head down map for Part 5, Peaks of Peninsular India, deep into the south. Right at the beating heart of the subcontinent sits the ancient Aravalli Range, peaking at Mount Abu. Then, dead center, is the Satpura Range. Because of its exact location, it catches maximum sunlight. It's actually perfectly reflected in the name of its highest peak, Dhupgarh, which literally translates to Sun Fort. How cool is that? And just slightly further east, you'll find the Michael Range, topped by the Amarkantak Peak. Now, here is a fascinating geographic anomaly. Usually, mountain ranges act as massive borders, right? Sprawling across multiple states or even countries. But the Ajanta mountain range breaks all the rules. Its entire massive geological expansion begins, exists, and ends, contained within just a single state, Maharashtra. It is a total anomaly. As we travel down into the deep south, the topography tells this amazing story of collision. The Western Ghats, featuring peaks like Kalsubai and Mahabaleshwar, stand as this continuous, unbroken physical wall. But the Eastern Ghats? They are completely fragmented and broken. And these two massive coastal chains literally crash into each other at the stunningly beautiful Nilgiri Mountains, creating this spectacular geographical junction.
But listen, out of all these towering southern formations we just talked about, there is one undisputed king. The absolute #1 highest peak in all of South India belongs to Anaimudi, located proudly right there in the Anaimalai Range.
Wow, okay, we have covered a massive amount of ground today in this explainer, from the violent tectonic crashes that literally birth mountains to the quiet, slow, relentless grinding of glaciers. So I'm going to leave you with this one thought to ponder. The next time you step outside and look at the horizon, which of these massive geological forces, be it tectonic collisions, ancient glaciers, or carving rivers, shaped the very ground you call home?